Let us start unit number 3, that is current electricity. Before going further, we should know what is current, rather electric current. जैसा कि 10th क्लास में पढ़ चुका है हमने, the definition of current, that is the rate of flow of electric charge is called electric current. I is equals to dq by dt. That means the current is represented by the term I, which is equals to the rate of flow of electric charge through any cross section. The SI unit is ampere, we all know it, which is denoted by A. So I will return it. ये एम्पियर जो यूनिट है ये आपने पहले भी पढ़ा होगा. इट इज़ वन ऑफ द फंडामेंटल यूनिट्स एंड ऑल्सो इट कैन बी रिटन एज कूलम सेकेंड इनवर्स. इस चैप्टर में सबसे पहले इंपॉर्टेंट डेरिवेशन जो आती है वो आती है फॉर द एक्सप्रेशन ऑफ ड्रिफ्ट वेलोसिटी. सो बिफोर मूविंग टू इट एक कंसेप्ट समझ लेते हैं. अभी हमने पढ़ा एक डेफिनेशन दैट the current is equals to the rate of flow of charge. Suppose हमारे पास है एक conductor which is not joined with any external battery. Conductors we all know that these are the pool of electrons. मतलब इस conductor में बहुत सारे electrons होंगे. So at a room temperature क्या होगा इसमें? Are all the electrons at rest? Are all the electrons moving? Are the electrons moving parallelly in any certain direction? What will happen? Let us understand. इसमें क्या होता है कि सारी electrons motion में होते हैं, but the motion is random. What is a random motion? Random motion हम उसे कहते हैं जब बहुत सारे electrons different directions में different velocity से move कर रहे हैं. Let us take an electron E1, name it 1. Moving with a velocity u1. So there will be another electron which will be moving in the opposite direction with the same velocity. So we can say that the average thermal velocity. Why we are calling it thermal? Because these electrons are moving in certain direction with some velocity due to the thermal energy. So the average thermal velocity will be the sum of velocity of all the electrons present in this conductor divided by the number of electrons. So what it will be? It will be equals to 0 because the motion is random at room temperature. Okay, remember this value because we will be using it in the derivation for the expression of drift velocity. So coming to drift velocity, the definition of drift velocity is that it is the average velocity of free electrons with which they are being drifted from one end of the conductor to the another in the influence of an electric field. That means हम एक कंडक्टर के across electric field लगाएंगे. तो हमने पहले चैप्टर्स में पढ़ा है कि if an electron is moving inside one electric field, then the motion of electron it will be opposite to the direction of this electric field, and the force applied on this electron due to this electric field it will be E into capital E. That means the charge on this electron multiplied by the magnitude of this electric field. तो हमने क्या किया, अभी एक कंडक्टर लिया. Suppose this is the conductor, this is of length L and it is being connected to a battery. इससे क्या होगा, बैटरी की वजह से दिस इज द पॉजिटिव टर्मिनल, ऑल द इलेक्ट्रॉन्स और नेगेटिव चार्ज विल बी accumulated here and all the positive charge it will be accumulated here. This will create a electric field inside this conductor. सिंप्लिसिटी के लिए हम क्या ये डायग्राम यूज करते हैं. तो ये डायग्राम क्या कहता है कि देयर इज अ कंडक्टर, इलेक्ट्रिक फील्ड हमारी इस डायरेक्शन में है, द मैग्नीट्यूड इज कैपिटल E, all the free electrons are inside this conductor. But remember one thing, there are not only free electrons in a conductor, also there are atoms, ions which are heavy, which are immobile in the conductor. So of course they will affect the motion of electrons, free electrons. एक इलेक्ट्रॉन की बात करते हैं. Suppose this is the electron. It is moving. Let us take this electron. Since the electric field is in the direction moving right, so the force on the electron, it will be in the opposite direction. This electron will accelerate towards left with a velocity v1. तो ये कोलाइड भी करेगा जो इसके रास्ते में आएगा. सपोज यहाँ पे एक एटम है, immobile atom. So it will collide with this atom. It will change the direction and then again accelerate in the left direction. So the path will be curved path. We can say that after every collision, the electron will follow a curved path. Now, again, let us assume there is another atom here. So it will collide with this atom, change direction, and then again accelerate. So the path will be zigzag motion. Again, there will be atom, it will divert. Now, in this case, the velocity or the average velocity of all the electron, it will not be 0. It will be of the order of 10 to the power of -4 meter per second. So this velocity is, we call it drift velocity. So now we will find out the expression for it. For an electron moving in electric field, the force it experiences is F is equals to minus E into capital E, where E is the charge on electron and capital E is the magnitude of electric field. So from second law of motion, ma will be minus E into capital E. Acceleration will be equals to minus E into capital E upon m. Now again, using the equation of motion, for electron 1, v1 is equals to u1 plus a into tau 1, where this a is the acceleration of an electron. This acceleration will be same for all the electrons because all the electrons will be kept in the electric field of magnitude capital E. u1 is the initial thermal velocity of electron 1. It will be different for all the electrons. For different electrons, this u1 will be different. And tau 1 is the relaxation time. That means the time between two successive collisions, because one electron, it changes the velocity only after a collision. Similarly, for other electrons, v2 equals to u2 plus a tau 2 and so on for n electrons. N. Now, as the definition says, drift velocity is equals to the average velocity of all the electrons. So it will be v1 plus v2 plus v3 up till vn divided by number of electrons n. Now we will put this value of v1, v2, v3 and vn from here. So we can say that vd equals to u1 plus a tau 1 plus u2, this is vector quantity, plus a tau 2 plus up till n times un plus a tau n divided by n. Now what we will do, we will separate these terms and write it as all the u1 will be separated. Initial velocities we will sum up n upon n plus acceleration is same for all. So I will write this term here plus a into tau 1 plus tau 2 up till tau n okay, up till tau n divided by n. So now this term in the previous derivation, it was 0 plus a, we will name it as tau divided by only tau a into tau. This is vector quantity where this tau is the average relaxation time which is equals to tau 1 plus tau 2 up till tau n divided by n. तो यहाँ से हमारे पास आ गया है Vd equals to a into tau. If you remember the previous derivation, a came out to be minus e into capital E upon m into tau. So this is the expression for the drift velocity. This is the important expression. You should remember this expression as well as remember the derivation.